Hi everyone, we're going to solve trig equations using the double angle identities. In this case, what I'm going to do is substitute, recall that there's three identities for the double angle for cosine. And the one I'm going to use is the one with the sine squared in it, which is 1 minus sine squared of theta. And I'm substituting there. And then after that, you can just treat it as a normal quadratic equation. Here we're going to get, if you combine these, you get 4 sine squared of theta. And I'm going to subtract the 1 at the same time. So that equals 3. Solve for sine squared of theta. And then you square root both sides. And don't forget your plus and minus. So you get sine of theta equals the square root of theta. Square root of 3 over 2 plus and minus. Your solution set therefore is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. These two solutions go for the positive square root of 3 over 2, and these two come from the negative square root of 3 over 2. Okay, here's another one. I'm going to do the same thing. I'm going to substitute with 1 minus 2 sine squared of theta. And if you notice, if you try to add 2 sine squared of theta both sides, it goes away and you get 1 equals 2, which is not possible. Therefore, there's no real solution. On this one, I'm going to use the double angle for sine, and there's only one. It's a very important one, but it's only one. I'm also going to subtract the cosine here and set it to 0. At this point, I'm going to factor out the cosine, and I'm going to get 2 sine of theta minus 1. Separate this out like we did in previous videos. In this case, the cosine of theta, we have theta, where the cosine is 0, is at pi over 2 and 3 pi over 2. For this one, I'm going to rewrite it as sine of theta equals 1/2. And in this case, we'll have theta equals pi over 6 and 5 pi over 6. And if I write this in order, from smallest to greatest, I have pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. So, that wasn't that bad. On this one, I'm going to use the other double angle for cosine. Since this side has cosine on it, I'm going to go ahead and use the one that's 2 cosine squared of theta minus 1. So I'm just substituting. Now, since we have it quadratic in form, I'm going to move the other cosine over, subtract it from both sides. Now, factor this out. It's a trinomial. And we're going to solve for this side and this side. This side's going to be cosine of theta equals negative 1/2. And this side's going to be cosine of theta equals 1. For the negative 1/2, we have theta equals 2 pi over 3 and 4 pi over 3. And for the 1, we have theta equals 0. So my solution set is going to be in least to greatest 0, 2 pi over 3, and 4 pi over 3. For the last one, it's a little different. I have it set up like this. So what I'm going to do is write my tan in terms of sine and cosine. Next, I'm going to cross multiply. So you get sine of theta equals 2 sine of theta cosine of theta. Now, I can go ahead and move the sign over. We get 0 equals 2 sine of theta cosine of theta minus sine of theta. All I did was subtract sine of theta from both sides from right here. Set this to 0. It's just like the other one. I'm going to factor out a sine, and I'm going to get 2 cosine of theta minus 1 equals 0. So set each piece to 0. In this one, we have theta equals 0 and pi. And for this one, we're going to have cosine of theta equals 1/2. And in this case, theta would equal pi over 3 and 5 pi over 3. Therefore, my solution set, writing from least to greatest, would be 0, pi over 3, pi, and 5 pi over 3. Okay. The next set I'm going to do involves more double angles, but they're a little more complicated. And then after that, we're going to do product to sum and sum to product type ones. Thank you. Have a nice day. Bye-bye.